Okay, so now if I do that same thing again, but I put a slash through, this still means one-to-many, but it now means it's required. And that, once we learn more about joins, we'll see that that would result in a inner join, the default join, the inner join. This one with an optional means it would be outer join. And we haven't really talked about joins yet, but you can have any possibility here. The one part is always going to have to be required. You can't really have a many, I don't think, without it. Well, maybe. Actually, you probably technically in the database, I think you can, but I'm just trying to think in the real world. I don't think that would make any sense. Does the order of the foreign key matter? No, it doesn't make any difference at all. Any other questions on the lab? Um, no. Um, Last Thursday there was a on-campus lab. I was in Building 19. I will do this from time to time. It was very short notice that I told you guys. It's at the request of a student, but I will do this from time to time. Particularly, it'll be a little more common when your labs are getting a little more difficult. Now let's see. Let's go. I'll quickly go through this section. I don't know that there's a lot to say. Indexes are sort of an important topic. Um, Let me know as I go through this, if you have any questions from the videos. All this detailed breakdown by me is on the YouTubes. Steven, do you have a question? Your hand is raised. Your avatar hand is raised. You need to type it. I can give you the mic. Steven, you can probably talk if you want. Okay. That's okay. Okay. And so let me know if anyone has any questions about creating it. You should have all created a new database for the world tables. All right, I'll go through it slowly, but let's see if this jogs anyone's memory about a question. Schema is another word for database. It's just it's just another name for it. You hear a lot of times, particularly database DBAs will refer to it very often as schema. We'll talk about indexes. Indexes are very important. An index on a database is a lot like an index on a book. It's a ordered list, and it's an alphabetical list in the case of a book. So if you want to find the word, index, or probably shouldn't use that, but if you want to find the word MySQL in a book, you go to the back and then alphabetically look under the M's and then the Y's and so forth, and you find the word MySQL. It will tell you what pages you can find the word MySQL on. An index on a table works much the same way. It's an ordered list, and it tells the database exactly where on the hard drive that piece of data can be found. So indexes greatly improve the performance of a database. Um, there is a maintenance hit with them um, because they have to be maintained. So if you update or insert data, then the index has to be updated as well. So there's a little bit of a hit on maintenance, but it's well worth it usually. Especially, you really just want to use it on columns that you would search on frequently, like name maybe or your social security number, things like that. If you search on that sort of thing frequently, you probably want to put an index on it. The database engines, I'm sure I went over this as well. My ISAM was the first one. ISAM stands for Index Sequential Access Method. InnoDB is a new one. This is basically was created to make MySQL more commercial and to implement a lot of functionality that's in more modern databases such as Oracle and SQL Server and Sybase and so forth. Generally, if you're doing something true production, you use InnoDB for most of your tables. Create table examples there. Any questions so far, everyone? It's important to know the difference between delete and truncate. That's usually a question in the midterm, and it's important. There's a distinct difference, so make sure you know it. Truncate is more efficient, but it's also much more limited. It's an all or nothing sort of thing. Indexes, again, I said are very important. Make sure you're reading that. They work on something called a binary search, which essentially cuts an ordered list in half every time it does a search. And because it's an ordered list, it knows where data will not be found, so it can disregard one half of the list every time. The end result of that is that a search, and it's also based on B-tree indexes and the binary search, which I might have somewhere. It's based on cutting a list in half every time. I don't know if I still got this one. Should look at this. B-tree indexes are also interesting, and there's a actual C code in there on how to implement it. Yeah, I don't really want to go through all this guy's C code. I just wanted to. Okay, so this kind of gives you a breakdown of how it works. Because it's an ordered list, like alphabetical list, it generally looks in the middle every time, and it says if the value I'm looking for is greater than the middle value, then I know the top half of the list can be completely disregarded because there's no way I'll find the value there. And it does again with the remaining half. It cuts it in half every time so that a 1 million row table can be scanned, worst case scenario, 20 times. If it was not an ordered list, then it would have no other choice but to do a sequential search. And in a sequential search, a million row table on average would be searched 500,000 times. Worst case, of course, would be a million. In an indexed one, a 1 million row table on average is searched 10 times. Worst case is 20, right? So indexes greatly increase speed. And when you go from 1 million to 10 million, it increases exponentially. You only actually add about another 4 or 5 searches to the binary search, which requires an index, versus sequential search. It now goes to 5 million and 10 million. So it's a huge difference. Indexes make a huge difference in finding data quickly. The downside, of course, is that so the primary advantage to the index is speed. The downside, though, is that it is a separate file or table or object, whatever you want to call it, that has to be maintained. So when you insert a row in the table, you have to insert a row in the index. If you update a table, if you update a indexed value in a table, you have to update the index. So you don't want to index everything, but key stuff that you search on a lot, like names, you probably would. It will greatly speed it up. And unique indexes just require that the value be unique. Any questions on indexes? Because that's a particularly important subject. How about truncate versus delete?